Welcome everybody. Today we're going to look at lesson number 7, and it's the first lesson that we're going to do on functions. And functions are really just a more specific type of relations. So it's nothing, the concepts in this next couple lessons are not new. We're just going to basically fine-tune what we know about relations. So before we jump into it, I would like you to go ahead and read this review here, and also do the little exploration here, because that's going to help you discover what really is a function and how it separates from other relations. Okay, I'm going to go right down here. So again, make sure you do all this here, the exploration part, on your own at home, and I'm going to go and jump into the definition of a function. This definition is a little bit wordy, so I'm going to go ahead and read it, and then I'm going to try and explain some of the key ideas in the definition. So first of all, a functional relation or function is a special type of relation in which each element of the domain is related to exactly one element of the range. If any element of the domain is related to more than one element of the range, then the relation is not a function. Okay, so let's go through that slowly. So first of all, a functional relation, right away that says that a function is a certain type of relation. Okay, and we call it a function. It's a special type of relation. Okay, so like I said earlier. Okay, now here's the little nitty-gritty stuff. So each element of the domain. Well, what does that really mean? Well, domain, we all know, is the x-coordinate, and the range is the y-coordinate. So what this is saying is that in each element, well, each element, that would just be like a coordinate. So if I gave you the coordinates 3, -7, okay, well, the x element of the domain is the 3, and the element of the range is the -7. So again, don't get caught up on the words here. There's nothing new here. So again, so each element of the domain, so every element, such as 3 or whatever, all the x coordinates, is related to exactly one element of the range. Okay, so well, this 3 is related to -7. If I gave you maybe a 2, 4, okay, well, that 2 is related to the 4, so that's okay. So these are all, the 3 and the 2 are the elements in the domain, and the -7 and the 4 are elements in the range. Now here's the key thing here. If any element of the domain is related to more than one element of the range, then the relation is not a function. So for example, if I had another coordinate that says 2, -3, well, that wouldn't be possible because now we have more than one element of the range corresponding to the element of the domain, which in this case is 2. So in this case, this would not be a function because the 2 has more than one element in the range. In other words, it corresponds to more than one y coordinate. Okay. Okay, I'm going to give you my own example of the best way to illustrate what a function really is by looking at a relationship of, let's say, a student's height and their age. So if I were to graph somebody's height versus their age, I would get my axes out. I would put the height, and we can call it height, and we can put it in inches, on the y-axis, and I would put age in years on the x-axis. And the reason I'm doing this is because the height is dependent upon the age. In other words, the independent variable always goes in the x-axis. So this would be your domain, or your x coordinates, and this would be your range, or your y coordinates. Okay, so keep that in mind. So we have the relationship between age and height. Okay, so let's look at how this might work for for any normal more or less anybody, the average person, let's call it. So if your age is 0 here, you can have your when you're 2 years old, when you're 4 years old, 6, 8, 10, and if we keep going here, we can have 12, 14. Most people stop growing by the age of 16, maybe a few, late bloomers, 18. And your height in inches would be maybe 10 inches, 20 inches, 30 inches, 40 inches, 50 inches, 60 inches. Well, 60 inches is 5 feet. So we should probably keep going because most of us will be more than 5 feet. So maybe 70 inches, and 80 inches is probably nobody's going to reach 80 inches. Okay, so when you're born, let me do the graph in green here. When you're born, well, I don't know. I don't really know. The baby might be 10 inches. And then you sort of grow steady. You grow pretty fast until you're, about in your adolescent years. You grow, and then maybe, maybe by the time you're sort of 8 years old here, you start to plateau off, and then maybe puberty hits, and you have a growth spurt, and then eventually you sort of flatten out, and you don't really grow anymore. Okay, so the green line here represents, the relationship of the height of your height in inches, of an average person's height in inches compared to their age. So what we see here is that if I wanted to look at how tall you were when you were 4 years old, I would just go down here to 4 years old, go up to the graph, and then go across to the height, and I can clearly see that coordinate is 4. When you're 4 years, you are 30 inches tall, and that works for most of these, for all the coordinates actually. If I wanted to see how tall you were when you were 10 years old, I would go here, and maybe you were 38 approximately inches tall. Okay, so what makes this a function is that if we look at our definition and how this relates to this graph, is that every element, in other words, all the ages of the domain, so each age of the domain corresponds to only one element in the range, and that's the height. So for example, for 6 years old, well, 6 years old only corresponds to one height. For example, if you're 4 years old and you're 30 inches, well, you can't be 30 inches and, let's say, 50 inches up here. Okay, that wouldn't work. I wouldn't be able to have a graph where I'm 4 years old and 30 inches, and also 4 years old and 50 inches. How can I have two different heights? And basically, that is the core definition of what a function is. You cannot have more than one output. And remember, these are your outputs here. These are outputs, and these are your inputs. So if I input 4 years old into my function, I'm going to get 30 inches. Okay, I'm not going to get 30 and 50. That would not make sense. So basically, again, what a function is, it's a type of relationship where every x coordinate or every input has only one possible output or y coordinate. Okay, so let's look at some examples down here. I'm going to go and skip this first, and I think I'm going to skip the second example, and I'm going to jump right to the third example here, and I'm going to start just well, I'll talk about the vertical line test in a second here, but let's go ahead and do example number 3. So determine which of the following are functions. Well, here we go. Let's look at this. So let's look at all our outputs. Sorry, let's look at all our inputs. We have 5, 6, -5, 2, and 6. Okay, this worries me right away because I have an input of 6, and here I have an output of 7. Okay, so that's in the range. And here I have an input of 6 again and an output of 8. So what this gives me, if I were to graph this, do a rough sketch of this graph, I would get 6, 1, 2, 3, 4, 5, 6, and then I would get 7. Again, a rough sketch here. Okay, that's that one there. And I would get 6 and 8, that's that one over here. And that is a problem because, again, the key definition here is you can only have one output. And in this case, I have two outputs for 6, 7, and 8. So this one would not be a function. Okay. All right, let's look at the next one. I have 3 as an input, 2, 4, and -3. And because they don't repeat, this is going to be a function because I'm not violating the rule of multiple outputs for each input. All right, let's keep going down and checking out. All right, so here we go. This one is if I input A, again, these are your domain or your input, and this will be your range or your output. Again, if I input A, the output is P. This might be like some sort of a code. If I input B, the output is Q. If I input C, the output is Q. So at first glance, this might seem like a problem, but again, if you look carefully, it does not violate our definition, because the definition of a function is you cannot have multiple outputs for the same input. But because the B and C are different, they're not the same input, they can both be Q. Let me go back to the height example to kind of illustrate what I'm talking about here. Okay. Here's our height example. And basically what they're saying is maybe eventually, you grow to be, 60 years old, and you maybe shrink a little bit in your height. You start slouching, your bones get old. And what this is saying is look at this. I have, I might be 45 inches. If I draw a line across 45 inches, well, look at that. I'm 45 inches here when I'm 14, and I'm 45 inches here, maybe when I'm, 70 years old. Sorry, this is not the scale, but that's okay. That does not violate our definition of a function. You're allowed to have the same output as long as the inputs, which are 14 and whatever this age over here is, are different. So that, back to our example down here, that is what's happening in this scenario, and that's okay because the B and C are different inputs. Okay, let's look at this one here. Again, remember the inputs are down here, and it doesn't matter what the values here are. Again, I have a problem here because, look, for this input, maybe that's a 2, maybe that's a 4, it doesn't matter. I get two outputs, and that is not allowed under our definition. This is basically the vertical line test, because if you draw a vertical line across your graph and you hit multiple, you cross the graph twice, or you hit multiple points, that is not allowed. So if I draw a vertical line, and look at that, there's 2 times I hit the graph, so that is the vertical line test, and it's a quick way of testing to see if your relationship is not a function. So I'm going to go ahead and cross this one out. This one was okay here. Okay, let's look at E, the relation connecting the provinces and territories of Canada with their capital cities. Well, that's definitely a function, because every province, again, this will be your input, and the capital cities would be the output. So if I input British Columbia, the output is Victoria. If I input Manitoba, the output is Winnipeg. If I input I don't know, the capital of New Brunswick, the output is going to be Fredericton, I think. So that's okay. If I, for example, did this for Bolivia, okay, for the country of Bolivia, okay, then I would have a problem, because Bolivia has 2 capitals, and I think one of them is La Paz, and I can't remember the other one, but it has 2 capitals, so the Bolivia, this wouldn't work for Bolivia. Okay. Let's look at these ones here. Well, this does, if I do my vertical line tests, I can see that for every input, there's only one output. So this is definitely going to be a function. On the other hand, here I have a problem, because if I do a vertical line test, I hit the graph multiple times, and that is not allowed. So that violates the vertical line test, and this is not a function. And basically, you can kind of look at that simply. If I input this value here, I get boom, 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 3 outputs, and that is no good. So this, if you're looking at your height here, well, this is a crazy graph to represent your height. you would be at this height, at this age over here, you would be 3 different heights. Well, that's not possible. Okay. Okay, go ahead and read this little section on the function as mapping. It's not too difficult, and I think, okay, I'll do one more quick example here, and I think you folks should be okay with this concept of a function. So if this is my sort of function here, and then the formula is 3x plus 1, well, these are all your inputs. So in order to find out the output, you just substitute in the -1 for x. So 3 times -1 is -3, plus 1 is -2. That would be the output. If I put in 0, it would be 1. If I put in 1, it would be 4. If I put in 2, it would be, well, 3 times 2 is 6, plus 1 is 7. So that's all that really is. So list the elements of the range of the function. The elements of the range are -2, 1, 4, and 7. Okay, I think you guys get the idea here. So see you guys in class, and we'll get to work on these assignment problems. Okay, thanks for watching.